Okay, we're on the last section. This is on page 360, I think. And it is trapezoids and kites. And yes, a kite is a real shape. And no, the shape didn't come first. The flying thing did. And then the shape came. So basically someone created something so awesome that it flew in the air, and then they came up with a name for it, and then they tried to understand it, and they called it a shape. At least that's the way I read the history. All right, so we need to know what trapezoids are, and that's what we're going to work on. And I don't know I wrote or. We're going to do both. It's an and. Okay, so the first thing we need to realize about a trapezoid is the definition. So on page 360, write down the definition of a trapezoid. And then we're going to need to draw out, we're going to need to draw out the shape and understand the different things about it. This works. Try to get one without a name on it. All right. We're zoomed in, aren't we? So I'm going to draw a trapezoid here, and then we'll see if we can get this named up. Let me do better than that, because we want to deal with what an isosceles trapezoid is, the difference between that and I'll just pretend that this is very isosceles-esque. Okay, the trapezoid only has one pair of parallel lines, only one. It cannot have two, unless you move to England, and then there's a totally different definition, and they call it instead of a trapezoid, they call it a trapezium. Because we can't do the same thing as England does, right? You know, we drink from aluminum cans and they don't. Where do they drink from?
Aluminium cans.
Yes. Aluminium cans. Okay? It's chemically it's the same thing, but the words are different. But their trapezoids or trapeziums are actually different. So if you go overseas, there are different definitions. We're going to deal with the isosceles trapezoid. And so what we need to realize with that is all these guys in blue are going to be base angles. And this messes with people's minds. Okay? Because this is a base, and I usually call it base 1, and this is base, and I usually call it base 2. Okay, it's like an easier version of baseball, just 2. I like to view the isosceles trapezoid as an isosceles triangle that got its head cut off. Because it basically follows the same rules as an isosceles triangle, where this side is going to equal this side. These angles, this angle equals this angle, and this angle equals this angle in an isosceles trapezoid. So that's kind of like a triangle. And actually the proof of all this is basically you take an isosceles triangle and do some things to it. So I like to look at this as all trapezoids as kind of like they're triangles, but they just are missing a part where someone cut it off and, you know. You ever do that with a Christmas tree, where you get a Christmas tree too tall and you just cut off the top? Okay, that's what I always do. Okay, because, you know, the top's not important, right? It's just the bottom.
Well,
Okay, well, see, the strategy there is you put the top half in the attic, and then it's still all there, right?
That's true.
Okay. So, no, I don't really do that. My trees are short.
Well, the bottom technically is the best part because that's where the presents go.
Exactly. Bottom's the best part because that's where the presents go. All right. Anywho, isosceles trapezoid. We need to know our things. Base 1, base 2, these are base angles. Okay, we need to write down all the theorems, and that's probably where we're going to end. We're going to write down all the theorems. And so that is theorem 714 through 16. And the most important one probably is 717, and that's where we're going to stop. This is probably the most important one, and I'm betting we won't have time to do this till part 2 of this, which will come tomorrow. So this is basically your homework, is to get these theorems written down so we can just knock it out tomorrow. So that's the most important one, so write those down. I'm going to shut this down, and it will be done for today.